In this example, we're going to describe a sequence of two transformations which maps the graph of y equals root x onto the graph of y equals root x over 2 plus 7. To emphasise how the order we do the transformations in makes a difference, we're going to give two different possible sequences that you could use. The first sequence of two transformations is probably the easiest of the two. However, until you get more proficient with these kind of questions, you may not immediately be able to recognise which order will be the easiest, so it's worth knowing how to do both. We'll begin by dealing with the plus 7. To get that, it makes sense to do a translation of 7 units in the negative x direction. That will get us from y equals root x to y equals root x plus 7. Next, we'll deal with the divided by 2 part. Dividing by 2 implies a stretch of scale factor 2. So we have a stretch of scale factor 2 in the x direction. That will get us from y equals root x plus 7 to y equals root x over 2 plus 7. If we do the transformations in that order, you should find that it's relatively straightforward. Let's have a look what happens if we try to reverse the order of the transformations. First of all, we'll apply the stretch of scale factor 2. That gets us from y equals root x to y equals root x over 2. Next, we'll apply the translation. If you've not got much experience with these questions, you'll see the plus 7 and think translate 7 in the negative x direction. We'll do that first of all to show you what the result would be. That would get us from y equals root x over 2 to y equals x plus 7 over 2. Be careful here, because if the x is divided by 2, whatever you replace it with has to be divided by 2. We can then see the problem if we separate out this fraction. Here we can see we've got x over 2 plus 7 over 2, so we've ended up halving the 7. Now that we know our mistake, it's relatively easy to fix. The minus 7 here needs to be twice as large. So if we change that to a minus 14, we can then follow that calculation through. Here we would have x plus 14. And then when we divide it by 2, we end up with x over 2 plus 7 as required. So as we said in the previous video, you may start to spot these mistakes before you make them. And so noticing here that we're dividing by 2, you would automatically change that to a minus 14 before you did the transformation. Right, here's a question for you to try then. Pause the video and then come back and check your solution against mine. Welcome back. Here's my solution. Be careful to check you've got everything in the right order. If you have, feel free to skip the next part of the video, but if you haven't, please don't just copy my answer, watch the tutorial, make sure you understand where it came from. Here's how I got my solution then. The easiest combination of transformations is to start with the translation. We'll translate by pi 0. That means we replace x by x minus pi. Next, we'll do a stretch of scale factor 1/3 parallel to the x-axis. That means replace x by x divided by 1/3. Rather than writing x divided by 1/3, we'll simply multiply by 3 to get cos 3x. And that gets us to our answer. So if you do the translation first in this question, it's relatively straightforward to get to the answer. Let's try doing the stretch first. So we'll do a stretch, scale factor 1/3, parallel to the x-axis. That gets us from y equals cos x to y equals cos 3x. Then we'll do our translation. At first look, you may think translate by pi. However, it's worth remembering that whatever we replace x by is going to be multiplied by 3. So it makes sense that what we put in the bracket here needs to be 3 times smaller. So we'll have pi over 3. Let's apply it and see what happens. Then when we multiply out our bracket, the pi over 3 will be multiplied by 3 to give pi.